This is worksheet 9.7, so we're going to be working with quadratic equations and parabolas, and using parabolas and the quadratic formula to understand the problem and solve or answer the question, rather. So this is worksheet 9.7. I'm going to skip ahead to number 5. Aaron Rodgers throws a football into the end zone. The height h in feet of the ball is given by this equation, where t is in seconds. So in other words, when we know the time, we can plug in that time amount for t and throw it into our calculator, and it will tell us the height of the football at that time. How long will it take the ball to reach the ground in the end zone? So the ball goes up, and the ball comes down. Boom. When does it reach the ground? So, whoa. In place of our common y value, we have h for height. So we can label the y-axis as height of the football. Height, and this is in feet. Height in feet. And we know that again based upon the time in seconds. Whoa, whoa, let go. There we go. Whoop, let's drop the ground down to there. Kind of cheated on that, but whatever. Time in seconds. Alrighty, so this, how long will it take for the ball to reach the ground? We're talking about this point right there. And we could answer the question by writing a sentence that would look something like, it will take blank seconds for the ball to reach the ground. So do we know any information about this point? We don't know the time, but we do know the height. The height would be what in feet at the ground? It would be 0 feet. So we're looking for this coordinate. Something comma 0, because our y or height is 0. So how do we find this? Well, this is what we call a solution to a quadratic equation. And when we graph things, the solutions are on the x-axis, and when we solve the quadratic formula, which looks like this, it gives us the values where y, or in this case h, the dependent variable, is 0. So we need to solve the quadratic formula to figure out the x value, or in this case the time that this happens. So a is -16, b is 64, c is 8. So we do the opposite of b, so -64 plus or minus the square root of 64 squared again, minus 4 times a times c, all over 2 times a. So we're going to get -64 plus or minus. Let's go to the calculator and figure out what that value is after the plus or minus. So we've got 64 squared minus, I said 64 squared minus 4 times -16 times 8. Whoa, that's kind of a messy number. We'll call it 67.88. You know what? Let's just call it 68. So Now, folks, when we subtract 68, so no, this is typically where we do our split. When we subtract 68, it's going to give us a massive negative number divided by another negative number. Well, let's do it. Let's try it. So we get negative 64 minus 68 divided by negative 32. So that gives us negative 132 divided by negative 32. And that gives us positive 4.125. And so that's one answer. The second answer we would get by adding it. So when I take negative 64 plus 68 divided by negative 32, I get 4 divided by negative 32, which is, we're going to kind of make this up, but I think it's about that. So which value would make the most sense for when the ball hits the ground after his throw? Well, here's our time in seconds. This solution right here, negative 0.1-ish, would be right there. So notice he threw it from, so actually he threw the ball when the ball was 8 feet high. So maybe he was jumping and then his arm was way up high in the air for the release. I don't know if he's actually that tall though. But anyway, that's 8 feet high right there. That's your y-intercept. This is the second solution rather from our quadratic formula. That doesn't make sense. That's not the answer to the question. The answer to the question is when the ball is at 4.125 seconds. That makes more sense for this location right here. Boom. Let's try number 6. An arrow is launched from the top of a 38-foot tall bridge. The height in feet is given by the equation that's there, where t is in seconds. What is the maximum height that the arrow reaches during the flight? All right, so we got a bridge. This is fun. We have a bridge. Boom. Maybe it looks like one of the lacrosse bridges. We have an arrow. So this is 38 feet tall right here. It gets shot off of there. And it lands sometime. So there's the arrow getting shot off the bridge and landing. The question is, what is the maximum height the arrow reaches during its flight? So where does that show up on this parabola? That would be right there. And this is the vertex. So to the answer to the question, the arrow reaches a height of blank feet. We need to figure out how high that is. Now, again, this coordinate pair, instead of it being x comma y, what variable is in place of our x's? It's t. And in place of the y is an h. If we know the time, we can calculate the height. So I need to know the time before I can figure out the height. So we will do the vertex x, or maybe I should put a t there. Whichever one you want to think about. We're going to get the independent variable here, which is the opposite of b over 2a. So that would be negative 112 over 2 times negative 16. So let's divide that out. Huh, that's funny. It is, isn't that what we just had right there on number 5? The same, oh, just kidding. There we go. So we get 3.5 seconds. Keep in mind what these values represent. So that's my time. at 3.5 seconds, the arrow reaches maximum height. So what is the height? Well, in the past, we've gone and made a table, an input-output table. Now this is time, or x, and this is height, or y. So we just want to know what is the height at 3.5 seconds. So we go negative 16 times 3.5 squared minus 112. Ooh, that's a plus sign. Plus 112 times 3.5 plus 38. And that gets us our height, or y value. So here we go. That's what our calculator is for. Again, I'm using Desmos Scientific Calculator. I think it works the best. Squared button's right there. Plus 112 times 3.5 plus 38. You get 234 feet. Did you see that? Is that right? 234. There we are. What we can also do is take that equation and put it in. So if you just want to double check it, if we made a mistake somewhere, we can type it into Desmos Grapher. Well, I'll do a t. Squared plus 112t plus 38. I wonder if I need a h equals. Well, that's a severe disappointment, isn't it? We only support, oh, all right, so that yellow triangle said they only like x's and y's, so I'm changing t's to x's and h to y's. There we are. So there's the arrow getting shot from that point at 0 seconds. Right when it gets shot, it's at 38 feet. It goes up and it hits the ground after 7 seconds. Ooh, I like that 7 seconds because we know the top of the parabola would be in between those two, which would be 3.5. That's the time, and 234 is the height. Good work, everybody. I'll do the next two on a different video because I'm not sure how long this took, and I only get 15 minutes.